we're going to go over the process of using real-world height map data in Unreal. In episode 2 of this series, we talked about creating landscapes in Unreal, and I showed you how to use the sculpting tools built into Unreal to define the shape of your landscape. During that video, I bet some of you are thinking, oh man, I have to hand sculpt my whole landscape? Can I just go out and download some data from the Earth and use that? Well, the answer is yes, you can. But there isn't a one-button solution. There are lots of hoops to jump through to get the data from the source and format it so that Unreal can use it. It's not a perfectly straightforward process, and it may take you a few tries to establish the pipeline that you want to use. So in today's video, we're going to be taking a look at 3 simple tools that you can use to get real-world height map data in Unreal. And then in a following video, we'll look at some more advanced sources and more powerful tools. First of all, before we look at the tools, we need to find out what kind of data Unreal is going to be looking for. So I'm going to pull up the documentation from Unreal's website, and I will link to this in the description below. Here you can see that we're looking at height map formats, and it says here that we need 16-bit grayscale ping. So we need a PNG file that is in 16-bit grayscale format. And then if we switch over to this other page under Landscape Technical Guide, you can see some resolutions that we need. So 8129 is the biggest file size that Epic is recommending here. 8129, 4033, 2017. So these are the resolutions that we're going to be using. So wherever we get the data from, in order to bring it into Unreal, it's going to need to be 8129 or smaller, 16-bit grayscale ping file. So there are a lot of different formats that the data comes in, but we're going to need to translate them into this format that Unreal is looking for. The other thing that's important to point out here is that Unreal assumes a vertex density of 1 vertex or a pixel in the height map. 1 vertex or 1 pixel per meter. So when we look at a size of 8192 here, what that's saying is that this is going to be a terrain that's about 8 kilometers square. It is possible to make a map that's larger than 8 kilometers square using a feature called world composition, but that's not something that we're going to look into in today's video. We may get to that in a later video. So we need to find a location in the world that is 8 kilometers or less, and then figure out how to grab the data from that spot to bring into Unreal. The first tool that we're going to look at today is called Google Earth. And this is something that you can download from Google, and I'll put the link down in the description where you can download Google Earth. And this is a pretty cool tool. It's really easy to navigate the planet. You can just kind of spin the globe around here and find locations that you're looking for. And you can even type in the name of a location. For example, if we want to take a look at the Grand Canyon, I can look at the Grand Canyon National Park in Arizona and hit the search button, and it's going to bring that up for me, and it's even going to zoom in here and take me right to the Grand Canyon. So the really interesting part of Google Earth is not necessarily, looking at it from out here. We're used to looking at things like Google Maps where you can see what the Earth looks like from a distance. But the really cool thing about Google Earth is that you can actually zoom way in close, and once you start getting closer, it turns into a 3D map, which is really cool. So here we are at the Visitor Center for the Grand Canyon, and as I zoom in here, if I use the left mouse button, I can kind of pan around the surface, and then I can hold down the middle mouse button to rotate around. And so you can see as I rotate here, it's almost as if I'm at this location, which makes this tool really great for scouting for locations. So it's really easy to instantly go anywhere on the planet and look around and see if this might be a location where you want to download Heightmap data. Now, the main drawback for Google Earth is that you can't actually download data from it. Google has this data copyrighted, and they don't give you any tools here for downloading color or height data. And so Google Earth is mainly a tool for scouting locations and finding data that looks interesting. And then you have to switch over to another tool to actually be able to grab or download the data. But it does make location scouting really easy because you can virtually go anywhere in the world. So pretty cool tool. The next tool that we're going to look at today is called Terrain.Party. So you can just type Terrain.Party into your web browser and it brings up this website here. This is another map, and you can zoom in and out of the map and find a location that you may want to download. Now, the interesting thing about Terrain.Party is it has this little blue square here, which allows you to define the location on the map that you want to download. So if I zoom out here, I can click and drag my blue square. Let's say I use Google Earth and I found that the Grand Canyon was the location that I was looking for. So I can use Terrain.Party now and come over to the Grand Canyon and find a spot on the Grand Canyon that I might want to download. I really like this spot where two rivers come together, and so I'm going to center my download area on that. Now, if we look over here on the right side, you can see that it says 18 kilometers, and that means this particular boxed area is 18 kilometers in size. If I hit the minus sign here, I can make my box smaller. And remember, when we looked at the data that Unreal needed, 8 kilometers was the maximum that we could import and apply to a single terrain. So I'm going to scale my box down, and now you can see that the smallest it goes is 8 kilometers. So in Terrain.Party, the smallest amount of data that I can download happens to be the largest amount of data that I can bring into Unreal. There are also a couple of other tools here. If I click this icon, there are a couple of different views that I can use. So here's shaded relief, and here's topographic imagery. Shaded relief may be a useful tool for you when you're scouting around and trying to find a location. Or if you want to see place names, obviously you'd want to use OpenStreetMap so that you could find locations. Okay, so now I know that this particular area inside this box is going to be 8 kilometers. And I can download this data. If I click the download button here, it'll say, what do you want to call it? And I'm just going to call it temp for now and hit OK. And it's going to package up a zip file for me, and it'll download that file in my browser. So if I open up this zip file, now you can see inside the file there are a whole bunch of different ping images, and each of them is labeled with the source data. There are a bunch of different sources where this data comes from USGS, from SRTM, from Aster, etc. The file that I want to use is this one called merged, because it takes the best bits of all of the different sources and pushes them together. Now what I want to do is open up this file, and I'm going to use Photoshop, but you're welcome to use GIMP or any other free image editing software if you'd like. I'm going to drag it over here and bring it into Photoshop and take a look. So this is the data that we got from Terrain.Party, and you can see it's this nice area where these two rivers are converging to help form the Grand Canyon. And this is pretty cool looking image data. You can see if we look up here in the format, it's grayscale and it's 16-bit, which is exactly what we need for Unreal. However, there is one drawback. If we come up here to image and go to image size, this data is 1081 pixels by 181. And that means that blue box that we were looking at, that we centered on, was 8 kilometers. And the file that we got from Terrain.Party was only about 1,000 pixels. And what that means is we now have an image that has a density of just 1 pixel for every 8 meters, whereas Unreal wanted 1 pixel for every meter. And so this is really low-res data. And the reason for that is this site is set up to be used for the game's cities skylines, so that you can make your own city building scenarios in that game. And cities skylines needs a Heightmap size of 1081. Like, no matter how large the area is, that's the size that cities skylines wants. So if we want to make a higher res Heightmap, or we want more dense data, we need to find another source. So Terrain.Party is really good for finding locations and knowing exactly how big they are, because we can put this blue box in an area and say, I know that area is 8 kilometers by 8 kilometers. But it's not so great for the data itself, because it's fairly low res, maximum of 1 pixel for 8 meters instead of 1 pixel for 1 meter like we're actually looking for. And that brings us to our next source of data, which is Tangram Heightmapper. So this URL is a little bit more complicated, so I'm going to paste it in the description. But it's this website, Tangram Heightmapper, which shows you the Heightmap data from the Earth, and you can actually zoom in and out and browse this data, and it shows you the Heightmap data itself. Like Terrain.Party, for example, is showing me other views like the OpenStreetMap view or the USGS shaded relief or topographic imagery. But with Tangram Heightmapper, it's actually showing me the real Heightmap, which is pretty cool. So I'm going to zoom in here and find this same spot of the Grand Canyon. And I've used Terrain.Party to determine that this particular area here, where the two rivers come together, is about 8 kilometers. So if I want to get some data that's more detailed than what Terrain.Party was able to give me, I can just zoom in closer using Tangram Heightmapper and capture this. Now there are a couple of tricks to this that I want to explain. First of all, let me show you how this works. If I click this export button here, it's going to do basically just a screen grab and give me that. I'll just do that and show you. So if I hit export, it's going to give me this screen grab image here. And I can then grab that and drag it into Photoshop. And so there's the Heightmap image that I was able to get from Tangram Heightmapper. But like I said, there are a couple of tricks to this. First of all, by default, Heightmapper uses this feature called auto exposure, where whatever is highest on the screen, it's going to make white, and whatever is lowest, it's going to make black. So you may see that it's changing brightness as I zoom out, and auto exposing the range of whatever it is I'm looking at. So if I zoom in all the way like this, whatever is the highest part on the screen, it's going to make white. So I need to be careful of that. And the other thing that I wanted to mention is that I can take screenshots, but the screenshots are based on the size of my monitor. Now I happen to be using a 4K monitor, which is nice because I can grab large amounts of data. But here you can see this screenshot is 3840 by 2034. So if I want to get 8K by 8K, I'm going to need to grab several of these and stitch them together. And so what I want to do is come back to the website, and I'm going to look on Terrain.Party and look at this area that's 8K. And what I want to do is frame this area inside. Maybe I'll just scoot this over a little bit so that I have it framed up a little bit more on the area that I want. Now what I want to do is come over to Heightmapper and frame up this area in my image here. And you can see these settings here, max elevation and min elevation, and it's going to be changing these as I move around. The numbers will adjust based on what's on the screen. And so what I want to do is find this whole area that I want to capture. And I'm going to line these things up visually so that everything inside this box is fitting on the screen here. So I'm basically just looking at geological landmarks like this shape here and this shape here. I can see are here and here. And so I've gotten this to a zoom level where my 8 kilometer area is fitting on the screen. And now I'm going to turn off auto exposure. And what that's going to do is it's going to lock my min and max elevation to these settings. And now what I can do is zoom in a couple more clicks, maybe 5 clicks of my mouse wheel. And now I'm going to grab individual sections of this area and export them out, and then bring all those images into Photoshop, or like I said, you can use GIMP as well. And then I'm going to stitch them all together so that I have a higher resolution version of my height map. So I'm going to go ahead and do that, and then I'll come back and show you what I did. Alright, here we are back in Photoshop, and I went ahead and took a whole bunch of export images from Tangram Heightmapper, and I brought them into Photoshop just like this. Basically, all I did to capture these is zoom in on the area with auto exposure turned off, and captured it, and then moved the camera a little bit, captured it some more. So I have this kind of a mosaic of my area of the Grand Canyon here. And I was able to piece it together here in Photoshop and just kind of lay it out so that all the pieces are in the right place. And then I took one of the pieces, and this is the height map data that I downloaded from Terrain.Party. And I went ahead and used image size to size this up from the original resolution of 1081 to 8129, which is the image size that Unreal wants for 8 kilometers. So let's take a look at this. This is the data from Terrain.Party, like I said. And I brought one of these screenshots from Tangram Heightmapper in and just laid it on top and scaled it up so that it's matching all of the little geological landmarks. So if I turn it on and off here, you can see that it's not perfect, but it's in just about the right place. What I discovered when I overlaid these is if I turn this on and off, even though my data from Tangram Heightmapper is a larger image, it's not any more detailed. Both of these images are basically coming from the same data source. And so I'm not going to get any data from Tangram Heightmapper that's any better than Terrain.Party. So basically, these are both the same. And zooming in on the image in Tangram Heightmapper is basically just blowing up the image larger. It's not actually giving me any more detail. And what that means is that I can go ahead and use the Terrain.Party image as it is without having to take all of these images from Tangram Heightmapper and stitch them together. And that's going to save me a lot of work. So I'm kind of happy about that. Even though I don't have terrain detail that's any higher than 8 meters per pixel, I'm going to go ahead and use this one, and we'll take a look and see what kind of results we get inside of Unreal. And then maybe next week we'll take a look at downloading some data that's more high resolution than this. I wanted to avoid doing that this week because there are a whole lot more hoops that you have to jump through for managing that data, and I want to save that until next week. So we'll go ahead and bring this data sourced from Terrain.Party into Unreal. So I'm going to go ahead and save my 16-bit grayscale ping from Terrain.Party into my Unreal project, and I'm going to save it in Unreal Projects, my Forest Stream Projects, Content World Maps. Of course, you're welcome to put yours wherever you want, but that's where mine is going to go. So I'm going to save it right there, and then we'll switch over to Unreal and import it. All right, here we are in Unreal again, and I've gone ahead and created a new map. Basically, I just went File, New Level, and I picked a time of day level, and I named it Procedural. And then I came over here to Modes, and I went to Landscape. So here's my new landscape dialog. And instead of creating a new, I chose Import from File. So now the next thing that I'm going to do is for the Heightmap file, I'm going to come here to the Browse thing, and I'm just going to browse to my location. And here it is. So I'm just going to click Open. And you can see that it's correctly detected the Heightmap resolution of 8129 by 8129. And the next thing that I need to do is to make sure that all of these settings here match the ones that Unreal is recommending. So they're saying 8129 by 8129, 127 quads, 2 by 2 sections, and a total of 1024 components. So that's it. Those are the settings that I want. And now I can go ahead and hit import. All right, so my landscape has been created. And if I zoom out here, you can see that I now have a nice shape of the Grand Canyon, which is pretty cool. I was able to get all this Heightmap data in here without actually having to paint anything. Now, if you feel like maybe the verticality of the canyon is not quite what you're looking for, you can match that up a little bit better to the real world data. In the zip file that comes with Terrain.Party, there is this README file with some instructions here on how to match elevation. And we're not going to go over that today, but you can go ahead and read through that and figure out how to match elevation exactly if you want to. Or the other thing is, if you just want to eyeball it, you could get out of terrain mode, select your terrain, and then come over here to scale. And right now scale on the z-axis is set to 100, but if I wanted to make it twice as high, for example, I could type 200 here in my scale, and now my terrain is twice as high. So, you're welcome to scale that however you want, or if you want to match real world data, you can follow the instructions in that README from Terrain.Party. Okay, so today we went over Google Earth, we looked at Terrain.Party, and we talked about Tangram Heightmapper. And I think what we decided is that Terrain.Party was the simplest way to grab Heightmap data, because the file that it gives you is already 16-bit grayscale ping, and you can just bring it right in. But we did find out that it is fairly low resolution, only 8 meters per pixel. And so next week, we're going to take a look at some other sources of data that could potentially be higher resolution. Now, if you have another method of getting Heightmap data into Unreal that you'd like to tell us about, please be sure to comment down below. I'd love to hear from you, and maybe we can share ideas with each other and find good ways of doing this. Anyway, so I hope you enjoyed this video, that this is useful for you in getting real-world Heightmap data into Unreal and using it instead of having to sculpt it all by hand. So like I said, next week we're going to talk about a few other methods of getting height map data in. And once we have a height map that we're happy with, we'll start creating a terrain, a landscape auto material to apply material to our landscape. Thanks for watching, and I'll see you next week.